Don Bailey, founder of Capitol Hill Consultants. Welcome, Don, with your presentation, Hackers the Movie, a Retrospective. Welcome.
Hello. Thank you. So, when I have to say I was really honored to get the invite to come out here and give a talk at the 10-year anniversary of Hack in the Box. It's exceptional the work that they've been doing for the past 10 years, and I'm really proud to be a part of this team. So I wasn't quite sure what to talk about. Because what do you do for a 10-year anniversary? That's pretty sweet, right? So I was thinking to myself, like, maybe we should just kind of take a step back from what we're used to, and instead of talking about really technical things, we should maybe kind of look at the overall progression of security and the industry, engineering as a whole almost, and see how things have been affected over time. So that's kind of what this talk is about. There are going to be, okay, so that's not exactly true. I actually have a packet in packet, as Travis Goodspeed would say, for this talk, but it's presentation to presentation. So there's actually going to be a second presentation later, but you'll know when it happens. There'll be a definitive switch. Anyway, we'll get to that later. But 1995 is when the movie Hackers originally came out. Okay? How many of us were actually in high school back then? I'm just curious. I was in high school. Anybody else? Probably a lot of you were even younger than that, right? Yeah, I'm hearing some laughter, maybe not. Regardless, I really didn't care much about computers at that time, right? I cared about girls. I cared about my friends, who I thought were the coolest things in the world. And I cared about fashion, most of all. And you can actually catch me on a bad day wearing this kind of stuff, even today. Don't ever catch me when I'm just about to go to bed, because this is what I look like. And I definitely wasn't thinking about phones. I wasn't thinking about cellular technology. I wasn't even thinking about mobility. You know, the laptop to me was a completely foreign concept. I had no interest in laptops whatsoever. But then suddenly I got this idea, right, from this movie that came out that made me kind of realize that there was a lot more to the world around me than the simplistic things that I was doing in my everyday life. The internet wasn't about AOL. And it wasn't about, figuring out the best way that you could talk to your friends. It was about what you could do. And that was a really cool idea. It was a very catalytic idea for myself and a lot of people of my generation, including, I'm sure, a lot of people in this audience. And if you look at the ideas that were presented in this movie, it's really interesting to see that they almost, in a lot of ways, predicted what the future would be like in internet security a decade later. And of course, it's been 17 years now, right? I mean, it's 2012. So they've been actually able to create a pretty good track record for a long period of time, signifying like the way that we see each other, the way we see our systems, and the way we guard our data, which really hasn't changed at all. And that's kind of what I'm going to get into here. So when's the last time somebody heard about passwords being dumped? Anybody? A couple of days ago? A couple of weeks ago? How many people actually run an internet security team for a company right now? Anybody? Yeah, put some hands up. I know there are some in the audience. There are a lot of people in here that are actually concerned about this because for some reason, we haven't migrated past the concept of password, right? Sure, we've got biometrics, some semblance of it, but it's kind of ridiculous. You can bypass facial recognition with a photograph. Biometrics on your laptop might mean a fingerprint if the reader is any good. But typically, we're still caught up in this idea of password. And what it means to have an identity on the internet typically means still having a password. A lot of solutions are migrating away from that. It's great to see Doug Song implementing Duo security with SSH and Google's authentication. All that stuff is exceptional. But for the most part, two-factor authentication is still foreign to most people and most organizations. And passwords are still something that we're going to use today, tomorrow, and probably 10 years from now, because it's just easier, right? We're just used to it. The other thing I found really interesting about the movie Hackers is that everybody was using a Mac. And we never would have thought of that like 10 years ago, right? Everybody had a Linux laptop. I've got a ThinkPad right now, but we have a Mac at home, and we use it for work. most of the people that I know that are hacking, they've got a Mac. Of course, unfortunately, we're not flying through cool screens and doing crazy stuff, but maybe Metasploit will get really, really good in the next 2 years, and we'll finally be able to start doing that. But it was interesting to see that they almost predicted this kind of change in behavior in the hacking scene. So we can fly through all the cool screens that we want, but really at the end of the day, we're hacking computer systems, right? Through those laptops, using passwords or whatever. But the other thing that they touched on, which I found was really cool, was hacking kernels. Most people back when this movie came out in 1995 were not talking about hacking kernels. Hacking a kernel was a completely foreign idea, right? Just like most of the other things that are brought up in this movie. But what's really cool, the first exploit that ever came out for a kernel was probably 8 Little Green Men. Mater, do you remember? I think it's 8 Little Green Men. And if I remember correctly, it came out in 1993 or 1994. And it was for either SCO, I can't remember if it was SCO or Sun. It was one of the two, but it was a divide by zero bug. And the divide by zero bug actually allowed you to execute binary in the kernel by taking over the interrupt vector, or I'm sorry, the fault handler for divide by zero. So you could actually inject code into the kernel that would be executed out of context in user land, and it would allow you to change your authentication credential structure in kernel memory for your process, thus becoming root, or whatever the super user was for that particular operating system, which was awesome, right? I mean, people never thought about that, and yet you see it in the movie Hackers. And today, what's everybody talking about in 2012? Kernel hacking. And primarily where? iOS, on your phone, right? There are a lot of other things going on in this movie that kind of threw me for a loop, right? Especially when I went back and reviewed everything. It was a little bit startling, right? And I want to divert a little bit to give myself a little introduction. So this is me. And I had to throw this picture. I really apologize because the picture that they put of me on the Hack in the Box website, I think I look like a zombie. So I actually wanted to put a decent picture up so you can see I don't look completely terrible all the time. So anyway, you might know me from hacking cars. I've hacked a couple of cars here and there that's been in the news. I'm also big on reverse engineering GPS tracking devices because I care about privacy and people's ability to bypass some of these new technologies we're seeing in GPS. I also gave a talk at Black Hat earlier this year about hacking roller coasters, which you can actually do remotely, interestingly enough, because they're binding them together with this new concept of technology called M2M, or machine-to-machine. I'll get into that a little bit, but I'm also very well known for breaking into phones. But I'm not really going to talk about that much. My new company is Capitol Hill Consultants. It's a think tank on security, but not just everyday security, not the security you think of when you boot up your laptop or your phone, but security as a whole. We want to threat model anything that might have an impact on our day-to-day business lives. And so we focus generally on cellular technology, because obviously that impacts a lot more than just your cell phone or your computer. It impacts everything that we do. It's not just the old brick that we used to see being handed back and forth between two people. Today, it doesn't just mean your smartphone either. There's a lot more to it. And it really means the future for all of us in a lot of ways, right? And that's what I care about. That's what we care about as a company at CHC, is defining what this new thing is. What's this new thing that we're going to see in technology? And it's primarily going to be cellular, the cellular of everything, right? Which is what M2M is all about. It's the Internet of Things, okay? The Internet of Things means I'm going to throw a cellular module on whatever the hell I want to, right? Whether it's going to be an ATM machine or a bird or a tree or whatever. There's going to be some way to interact with that through some kind of long-range technology. And there are some astounding examples of things that are changing today. And this is actually a perfect example to me, because people think I'm kidding around when I say your tree is going to be cellular enabled. It's ridiculous, right? But no. We're actually seeing changes in very interesting green-friendly, ecologically friendly technology that enables things that you would never thought of being wireless to be wireless. The full alert is a very good example of that. This is actually a little bit older than M2M technology, but it's migrating from the old analog technologies to cellular. And what it does is it allows people that are birthing horses to determine when a new foal is actually coming out of the mother horse. Because you can't sit around, you have no idea when this baby is going to come, right? And you can't stand next to the horse all day because as a farmer or rancher, you have other things to do. You don't want to pay some field hand to sit and stare at a horse and decide when this horse is going to give birth. And if you've ever given birth to a horse or helped with it, then you know that taking the horse out of the mother is something that you actually have to help with. They can rarely do it on their own, surprisingly. You have to actually help or else they get stuck and it can kill the mother and the child. So what they've done is they've actually integrated wireless technology into the horse to determine when that horse starts to breach the birthing area. You get a wireless signal, and that signal is sent out to a transponder, which then connects back out to some receiving system. Now they're enabling some of these technologies over cellular, where you can actually get a little text message and say, hey, baby foal is starting to come. Here we go. That's really exciting to me because it shows that we're actually starting to link our physical world and our technological world in ways that we never would have thought of, even 5 years ago, 2 years ago. And now it's not only conceptualized, but it's happening. And that's really exciting stuff. Another great example is tracking cows. You would never think that you would need to track a cow. But they're learning a lot about the way that animals are grazing by tracking them in the field and using Zigbee and 802.15.4 technologies to determine the position of a particular cow. There was actually a research where they figured out that if they looked at images of cows at certain times of day, they would all be aligned with magnetic north. And they had no idea why these animals were aligned to magnetic north, but they'd all stand together in the same direction. And at first, if you look at images from around the world, you'd see like, wait, that's weird. They must just all like standing in the same direction. Well, the research allowed scientists to determine that it had nothing to do with them wanting to be cool and standing the same way as the cool cow over here. It had to do, they were actually aligning themselves with magnetic north. That's weird. That's surreal. But the cool thing is that we can see that with modern technology. Never would have been able to see that 5 years ago, 10 years ago. Okay? But now we can see that with M2M technology. So this is allowing us to see things that we never would have even had a concept of before years ago. Another excellent piece of technology, this is getting more into security, is the Shotspotter. A lot of people, when they see this technology, they think it's actually, what's the term I'm looking for? Microwave. This is not microwave. This is actually a percussion receiver. So when you shoot a gun, there's a burst of air, right? There's a bang, percussion. What happens if you have a device that catches that percussion occur and then triangulates the location of the object that emitted that percussive sound or pulse, okay? That's what Shotspotter does. So in the United States, technology was developed to say we have too much crime in Detroit or St. Louis or any other given big city in the United States. And they figured, how do we reduce crime? Well, they thought, if we can enable the police with enough information where they might be able to figure out where the highest crime areas are, because some of the people that are affected by these crimes in certain areas, they don't report them because they're scared. So the statistics are very misleading. And the Shotspotter technology allows police and investigators and dispatchers to understand not only where is a shot occurring, the direction of where it's going, and whether the shooter is traveling. So with multiple Shotspotter units, you can actually triangulate where a particular individual is that's making a gun shot and where they're going as they're shooting. That's exceptional technology. And what's even cooler is you can define what the particular device is that's emitting the percussive pulse. So you know whether it's a .45 caliber gun versus an AK-47 versus an MP5, etc. Because you can differentiate those pulses and factor in variables to determine whether or not you can actually sense, yes, this is a gun that I know. That is cool stuff. And this is life-changing, world-changing technology. And it all runs on the cellular network. These are all wireless devices that are enabled all over a city, which talk back to a centralized server. So it's a sensor unit connected to a cellular module, connected over a network to a back-end system that processes the information in a unique way. Great stuff. And of course, you know, when you bring up M2M, you always have to bring up SCADA, because they intersect so perfectly that M2M and SCADA are now almost becoming one unified technology. Okay? So SCADA, as a lot of you know, is control of oil and gas systems or anything to do with our physical energy-based environments. M2M is the ability to remotely control those SCADA systems over a cellular link. So now it's not just some computer sitting in, you know, the corner at a physical location in a oil refinery that's connected to some other network that's receiving sensor data. Now that sensor data is piped back to a back-end network in a completely different way over a cellular link that you can have any engineer in the world, if there's a problem, bam, solution. Because some guy that's an expert that you never would have had access to in Kuala Lumpur or wherever now has the ability to reach into your network and diagnose whatever the problem is. So that's very cool. Hackers was onto M2M way before anybody else was, which is just mind-blowing to me. It's hilarious, right? To think that a movie was doing this before everybody else. But it's true. The scene where he's actually, Zero Cool, okay, is hacking into OTV, the television network. Sure, it's fantasy, but the reality of it is you can do that. You can hack into M2M-enabled television network systems, actually surprisingly quite simply. So this is a BGAN technology from Harris, and Harris, of course, is a defense consulting or a defense organization, engineering firm based out of the US, I believe. I know they're international, but I think they're based out of the US. Anyway, they developed this awesome piece of equipment called a BGAN satellite transponder. And essentially what it is it's satellite phone technology, but it's data, right? So a lot of companies have this. I'm just showing the Harris model because it's got the coolest picture. But essentially what it does is it interlinks one group of individuals, usually reporters or agents or even soldiers, somewhere in the remote field, over a satellite network to an organization that's central that can analyze the data that's incoming from that team. So what's actually occurring is we're seeing an increase in usage in BGAN technology or other remote satellite-enabled M2M technology to broadcast reporters that are in Libya, Syria, anywhere in the Middle East, or anywhere in Africa where there isn't a decent uplink. They're using BGAN technology to shoot and upload their video streams to their home networks, Fox, CNN, Reuters, whatever, okay? Now, what do you think the weakest link is, especially if they're shooting live? If they're shooting live from Somalia, right, and the BGAN link is probably like a 5 to 10 minute delay, where do you think the biggest, weakest link is? The network that you have to completely own, like every piece of it, to get into some computer systems that run Fox's broadcasting, or the BGAN link, or the satellite channel that facilitates the broadcast from the reporter uplink and back down to Fox News or whomever? It's the satellite. The M2M link is the weakest piece of the puzzle. Okay? So it's entirely possible today to perform the same action. Also, another cool thing is everybody remembers this scene, right? Because the pool on the roof must have a leak. And suddenly the sprinklers are going off. Well, in this movie, they hacked the sprinkler system, and suddenly it's pouring water on everybody because this guy decided that he was going to get revenge on some girl that tricked him. Well, the reality of it is, yeah, we can totally do that. We can do that today because a lot of pieces of equipment for buildings are designed to accept M2M cellular-enabled communication to control the entire building, from lighting to alarm systems to security functionality to opening and closing doors, all different kinds of pieces of now be unified under M2M and R. All over the United States, we're seeing these technologies enabled. So now these big, huge panel systems that you would normally see in a secure little box inside of some office skyscraper in downtown San Francisco, they're getting quite small. All the functions. into a back-end system where all you have to do is hijack the 2G, because GPRS isn't that difficult to hack anymore, right? Because we all have OpenBSC. You can easily intercept some of the communications because most of these systems are not capable of SSL. Okay? And the ones that are capable of SSL, if you're using SSL on a small embedded system, what's the likelihood that you're going to waste the extra megabytes to put a root cache on there? So the actual SSL root certificates, not even on it. Sure, it's using SSL, but it can't verify anything, right? So the alarm systems that are riding over this technology, boom, owned. So that's a reality. Obviously, this is the bigger concern, right? We're going to cause a worldwide ecological disaster just to catch some hacker kids? Yes. Because you can do it. The reality is that this technology is also M2M enabled over essentially long-range satellite SCADA links. Okay? This is another type of BGAN technology, but it uses protocols that have been authorized for maritime use. And what's even more interesting about this, the satellite systems that exist on the boats are interconnected with Zigbee systems for oil refinery technology that sits on the actual boat as well. So you have M2M technology riding over BGAN, or whatever cellular protocol link that you have, and then on the oil refinery ship or whatever station, you actually have back-end connections to Zigbee 802.15.4. So you can attack it either over the cellular network or over the 802.15.4 network, both of which are relatively insecure. And then you are able to compromise the ship's controls from that point. NCIC database is another great example in the United States. We use this to monitor and store data on millions of Americans. It's the criminal database that we use. The reality is here, this is also interlinked as well, right? Because the laptops in police cars are all back-ending over cellular technology. What's interesting is that they're now being connected with sensors in the vehicle. So the sensors in the vehicle denote, like, you know, what's the pressure on the brake systems? Is the air pressure in the tires low? What does the video link say for the camera on the dashboard of the police car? All of these aspects of the vehicle are now back-ending through the cellular link because they're all wirelessly enabled, again, through M2M. So I'm not even going to get to the traffic stuff because you've got enough examples already, right? At the end of the day, we've got tons of technology here, tons of examples, and they're all completely different. And we would never think that they could be owned using one singular technology. But they are, because M2M, the protocols that are used for cellular and satellite M2M are all the same. Okay? So if you're able to compromise one link, it's very likely you're able to compromise similar links. So what does all of these different kinds of attacks tell us? It tells us that laptops are no longer the target, right? Server system backend databases are no longer the target. What this tells us is that real hackers hack. And real hackers hack everything, right? From the ATM to your cow to, yeah, to your cell phone to absolutely everything. Real hackers hack. And what's interesting about real hackers that hack is that they're extremely patient. Where's DF? DF, are you in here? No? I got to give a shout out. Yeah, there you are. You're in the back. Who've been very, very good to me over the past few years. Sorry I didn't wear the shirt, but I wanted to give you some shouts. But I wanted to diverge a little bit into real hackers hacking and do my little presentation talk. So we're going to switch modes a little bit into a different presentation. And hopefully this still works. All right, so this talk is called Marsh Ray Has an Idea. And this is where Real Hackers Hack comes in. Because he had a great idea. Does anybody here follow me on Twitter? Anybody? I don't have that many followers, so it's probably, okay. A couple guys in the back. Hey, guys in the back, Do you remember me having a conversation with Marsh Ray in the past couple of weeks? Yeah, because nobody's really paying attention to what I say. That's okay. That's a good thing a lot of the time, because I say a lot of stupid stuff. Anyway, Marsh had this really interesting point about SSH. So OpenSSH, as we all know and love, has been hardened, seriously, over the past X years, right? I mean, nobody would ever think that somebody would come up with an OpenSSH exploit, let alone a 0-day, God forbid, right? So Marsh came up with this really interesting idea that, of course, had been done, but not publicly. So what he thought of was, what if we have an SSH server? What if people connect to that SSH server, but that SSH server doesn't care and just accepts any key that it wants? And what if, instead of giving you a shell, it immediately prompts for your private key? It simulates, oh, this is a simulation of what it would look like if your password were requested for your private key on your local system, right? Most people are probably just going to say, oh, well, I've already authenticated to the system or whatever, or I need to yet authenticate to the system. They're not really thinking clearly at that point, so they usually just type in the password and go along about their day. Well, it was a really interesting point because nobody had publicly said that before. What if we do this? That's a weird idea. How about if we just do this weird thing? Well, it was really cool, and my response to Marsh was, and I apologize for, I'm going to swear, I said, damn it, Marsh, because I was annoyed. Because this is something that people have been using as a trick for about 10 years that nobody had ever talked about, oddly enough. So what occurs is when you dump into somebody's SSH server, the SSH server just runs a program and prompts you for, okay, what's your private key? All right, thanks for your private key. Now I'm going to drop you into a shell. All right, so that seems a little bit ridiculous, right? Because that seems like, well, there are so many other things that you would have to go through in order to make that valuable. Like, how would you ever use that legitimately in an actual real-world attack? That sounds ridiculous. That would never work. Well, there are a lot of reasons why it's more dangerous today than ever before. And I'm going to show you some demos that will point out hilariously why this is such a hilarious, funny thing that Marsh, I wish he never would have tweeted. So, the basis of this idea is that trusting people is ridiculous. Why would you ever trust anyone on the internet, right? You would never do that. You would never trust a person. But reducing SSH is always going to point out that you're trusting the individual. Moxie was very well quoted recently in saying that you can reduce SSL, right, if the client side is implementing crypto to the client trusting the server. Public key. Because if the server is shipping crypto algorithms in JavaScript for the client to execute in a web browser, it's validating the public cert of that server first and then saying, okay, well, I'm going to use this crypto now. Well, you can reduce that entire process to trusting the cert of the server. We're doing the exact same thing in SSH and we don't even realize it. But we're doing it with humans. Because you no longer trust the server, you trust the individual. Because the individual has to authenticate what? The server key. Because what occurs when there's a mismatch of the server key? Big, huge error. OpenSSH blows up, freaks out, and scares everybody. And says, no, you shouldn't trust this key, but maybe it's just a key change, so it's okay. So that means that you are actually trusting your users to do the correct thing when they are presented with a problem. Right? So what occurs after that state? Well, transparent SSH version 2 man in the middle, which isn't really SSH version 2 specific, it's any SSH in general that's used because you just bypassed host-based authentication, which is silly. You should never trust a host-based server or a change in a host key, but people do, blah, blah, blah. That's not necessarily interesting. But what we're going to look at is why it gets dangerous, okay? So I'm going to give you a little demo. Here's Linux Mint. Here's the latest version of Linux Mint. I'm going to switch over here real quick. You'll have to excuse my slowness. I'm not the quickest guy when it comes to computers. All right, so let's take a simple client. Mint is getting extremely popular for desktops. And I'm seeing it more and more and more in red teaming. Okay? And it's interesting because people can deploy it very quickly, and you can actually have diskless client systems, which makes it great if you have a bunch of developers, engineers hanging out. So what you can do is just launch up Mint sessions for everybody and give them, keys and do your thing. So this is just a regular box. Nothing crazy going on here. It's really standard, but it's up to date. So what you'll notice is that I have no identities, my SSH agent, right? You can see that pretty clearly. The resolution kind of stinks. Can people see good enough? Guys in the back say no. We'll move up front then. Lots of room down in the front. Anyway, point is, we're going to do a little SSH Key Gen, okay? Tool we've all used before. We're going to create a type of DSA and store that in our SSH home directory, or the SSH directory under our home directory. Totally standard stuff, right? This is retarded. But, oops, don't overwrite that. So we'll generate our key. Bam. We've got a key. Now, at this point, you would do what? Load the key into your agent, right? Well, bam, already done. I didn't do it. How did that happen? Anybody? What's occurring in the background is whenever you launch a new session in Mint or recent Ubuntu distributions, there's a key agent that runs in the background without you telling it to, okay? And it just sits there and accepts any keys. And what's even more interesting about this is that it auto-loads every single thing that ends up in .ssh. So every single key that ends up in that directory, whether you put it there or not, is auto-loaded into the key management system, okay? So what you'll also note is this is not a regular SSH agent. It is, but it's not. It's actually managed by something called keyring. And you can see there's the SSH authentication socket right there. So it's actually being hijacked by a separate application that then is talking to an SSH agent legitimately. So what I'm going to do now is remove the files, remove lol and SSH add. I haven't done anything special. Agent has no identities. It's auto-adding, auto-removing, okay? So what we're going to do is just regenerate the key. Doesn't matter what key. Bam, there we go. Now I'm going to SSH into a server that would, be in my production network. Wow. So what we'll do is we'll add this. Oops. So I don't have any other keys. This is the only key there. So the key that I've just generated is now on my server in production, another virtual machine on here, okay? And now you'll notice whenever I SSH into that server, bam, it's using my SSH key. So there are two hosts, which is why you saw the error that just occurred, but we'll get to that in a second. This is the legitimate server, which is NetBSD, and I'll show you here. Bam. Who? Don B. Don B is from client1.cell.risk. Okay? So this is a NetBSD server. Then I also have a second server here, which is the transparent man-in-the-middle server. This is FreeBSD. Okay? Different operating systems. I wanted that to be very specific because we'll get to that in a second. So now I have my authentication key loaded in the target server. Okay? So what occurs now? We've got a second demo. The second demo is that SSH agent auto launches. So just for clarity, we'll just go ahead and log out. So as you can see from what I discussed earlier, if I log back in, SSH add, bam, there's the key. If I try to SSH back into cluster, if I go into the valid server, boom, there you go. I'm there, just like normal SSH stuff, right? So, what's very cool is that SSH agent forwarding is getting more popular than ever. It's extremely important because SSH forwarding is extremely dangerous. Authentication forwarding is probably the worst thing you can do. And we're seeing it everywhere now in production. Because what people are doing in order to secure the backend production systems or staging is they're setting up a proxy server. They're telling all their developers, SSH into the proxy server because it's secure, and then from there you can hop into any backend system that you want using authentication forwarding. Because agents are now baked into all of your Ubuntu desktops. So boom, there you go. Easy peasy, everybody can do it. Nobody's worried about problems. But now here comes the transparent attack, right? So all we do is just SSH to, whoops, look at that. Something bad occurred. Now, just to make sure that we're running along here, I'm going to remove the key for the legitimate server. I'll get back into that later, but for now, for example's sake, we'll get rid of that. And I'll SSH into the fake server with authentication forwarding like I'm a developer going into my backend system. Bam, there I am. So now, as you can see, welcome to NetBSD. Uname, NetBSD, and who on my FreeBSD server? There I am. There's Don B, and there's Don B. Okay? So, the most fun thing that you can do here is obviously when I start typing, hello, I am Don. On the transparent server, I can see it. Okay? And I also have write access to everything that that individual does. So now I can start executing commands, PS, blah, blah, blah. I'm going to pretend to sue, all this other crap. So now you essentially have access to that server as that particular individual. Great. All right. So transparent SSH man in the middle. It's cool. It's kind of been done before, right? So the biggest part about this is one particular issue that hasn't quite been defeated. And people bring this up all the time because when you have transparent man in the middle and you're forwarding, people always say, well, the only way that I can get around that, or like the easiest way that I can get around that, is if I do SSH add and I force confirmation, right? So now if I'm confirming, then I just go to cluster. And now what occurs is I see 1, 2 instances of the confirmation of the key, okay? So obviously you know that something bad has occurred because you're seeing the authentication occur twice. And you should never see that occur if you're attacking somebody, or you should never let them see something like that occurring because it's a complete blow over your cover, right? You know that they have requested that your authentication occur twice, so you know that more than one system is likely using that token. More than one system is using that token improperly. So there's a solution. And the solution is a little thing I've designed called lol SSH. So lol SSH is very simple. It just launches different things. Oops. And apparently it was working in the room, but it's not now, for obvious reasons. So I will fix the script. And there you go. So switching servers. And now if I SSH in once, Now using special code, I can trick it into performing authentication forwarding without using the key multiple times, which is supposedly impossible, right? Because every single time that a server requests authentication, it offers an SSH identity, or I'm sorry, an SSH session ID, which would be unique. And because of public key security, I should never know what the identity is of another particular server because I can't encode correctly, right? So I can't pretend to be another server if I don't have that server's key. So I can't just hand off and do like a passive man in the middle. There has to be some special sauce there. But you can't tell where this is coming from. So it's really important to notice that whenever you're using SSH authentication forwarding, and this occurs, notice what's not being shown to you. Can you see which server is requesting that authentication token or that challenge? You can't. It's not provided to you. That information is completely transparent to the user. So you hit that once, and bam, there you go. And it's the same thing. Watch, dev, pts 0. Now I have control, okay? Very simple. And it's getting even more dangerous on embedded systems because we're seeing more and more embedded systems performing this kind of thing. So, everybody's going to say, well, the next big issue is locking, right? So everybody says, okay, well, Don, I can lock my agent. That's true. You can lock your agent, except for one main thing. And I'm running out of time here, so I'm not going to start describing why SSH locking doesn't quite work. What I am going to say is this. SSH locking doesn't work for two reasons. Number one, locking your SSH agent occurs after you've already handed off your token to a server. So the server authenticates you, and then only afterwards do you have the chance to lock your actual agent, okay? So there's a window of time between when the server authenticates you and you have the ability to lock. If there's a command executed by the server within that window of time, the server can then harvest all the tokens or whatever they want to, attack your agent, do whatever they want to within that window of time. You have no ability to control that because the server defines when that session starts to go from authenticated into a shell. And because you can't do that in parallel, you can't tell your agent, I only want to accept one token. Only one token is going to be allowed to pass through. Well, sure, only one token is going to be allowed to pass through. That software isn't even written into OpenSSH, right? But even if it were, it wouldn't matter because if you say, I'm only going to allow one token to be authenticated, I've just shown you that I can do it with only one token, just like a regular server, but doing transparent man in the middle, okay? So you still can't lock. And if you do actually execute an SSH lock, then the individual who takes control of the transparent server has the ability to brute force the lock. And I wrote some SSH code. And actually, I'm not going to spend the time to show you this because I'm running out of time. But essentially, here's some code. It's all Go. Here are the lines of code. It's 481 lines. This is basically an agent brute forcer. And not just a brute forcer as in password brute forcing, but it also injects and extracts keys and commands, etc., from the SSH agent. So, the entire point of this is that software that you are using today, you still can't trust it, right? Everybody trusts OpenSSH, but given certain parameters, there's absolutely no reason why you would ever trust OpenSSH. And people say, yeah, Don, but you're still forgetting that you have to authenticate the host. Yes, that's true, but there's actually one specific instance where there is where you have a significant opportunity to attack people that even trust their host servers and their administrators, and that's ECDSA. And this is an extremely simple trick. This is not a real hack, but again, we're talking about hacking, right? The simplest hack that gets you in is the win, and this is the win, right? Everybody switched over to ECDSA, which caused millions of servers worldwide to suddenly generate an ECDSA cert. that nobody pre-authenticated and said, oh, I'm going to grab the actual key that was generated on my new server. Because what happens is the ECDSA is now being the one that's offered to the client, and the individual says, oh man, I'm going to accept this because I know that I just updated, and I just updated to the ECDSA code, and that's going to generate the new server and going to offer it to me. So there's a window where now a lot of people that are updating or changing from DSA to ECDSA, they just automatically accept, oh yeah, it's an update. No problem, I'm just going to accept that key because I know it should have been changed, right? And that, of course, is the perfect time to implement this kind of attack. And if you have the ability to do only one key, or request the key only once, then absolutely nobody has any clue otherwise. The only way to determine whether or not that is a problem is whether or not your source IP of the client that's connected to the server is still valid, right? But there are ways to change that. If you are a government agency and you have a server sitting in line in somebody's ISP, you can forge both the source destination, or the source and the destination of the process, of the IP connectivity, which allows you to take over the entire thing transparently and simulate both client and server IPs to make it completely transparent. It's entirely legitimate. So the ECDSA is probably the best window of attack. And what's really important to note is that ECDSA, the new keys, whenever there's a new protocol or a new key or a new type of key implemented in SSH, it's not signed by the previous keys. So you don't get like the trusted RSA server key that you've been using for 10 years. It's not signing the new ECDSA key and saying you should trust this now. It's just offering you the new ECDSA key. Either you accept it or you don't. There's no further validation except the user themselves is deciding to authenticate or not. So again, SSH is to the individual. So when timing is right, hacking is extremely simple. When timing is right, even the most secure technologies become extremely weak because users don't know what to do. And when you tell them to expect something, ECDSA is coming. If you see a key change, it's cool. That's when we see failures. Okay? And this works unbelievably well, especially in engineering firms when you're doing red team pen testing. Okay? So, 0-day doesn't just mean some elegant exploit that's taken you 3 months to get right. Okay? 0-day sometimes means the simplest, dumbest thing that you can do to get you the win. And these are simple, dumb techniques. Okay? I mean, people have discussed transparent SSH man in the middle since 1998, right? But nobody talks about it today because it's been solved. That's not true. We need to keep telling our users over and over that real instances of security breaches will occur if they do not understand the risks involved when new technology is deployed. Okay? So, we're going to switch back here. To the normal presentation. And I'm going to give you one last piece of fun before we move on to the next talk, so I'll make it quick. So, crash and burn scene, where everybody's hanging out at the end being happy because they hacked the planet, right? They're sitting here using what? They're hacking using, again, M2M technology, okay? So the reality of this is something called Enocean. And this is really fun. This is a great little toy to play around with. Enocean is really cool technology. It's wireless, but it's green. It's eco-friendly, meaning that it actually receives battery power harvested from regular ambient light. This is wireless signals. Okay, so it's really cool. Enocean actually enables environmental lighting, environmental control, just like you would see with Zigbee, but it's way more eco-friendly, like I mentioned. So it's becoming extremely popular, especially in the EU, and it's really easy to interact with. In fact, they try to keep the details of their protocols private, right? But you have to pay for it. And what's really funny about that is in the United States, there's something called FCC, where everybody has to file for an FCC authentication or authorization. Like your RF product has to pass FCC standards, and you have to submit all this information to them. Well, the thousands of dollars that you would normally have to pay for one of these pieces of documentation, you can just browse the FCC website, look up Enotion's FCC authorizations, and see like, oh, all of their user data is actually filed in here publicly for you to consume. So you can bypass spending thousands of dollars on the documentation, go straight to the FCC, and it gives you all the details about the protocol and how to interact with it. So it's just ASC modulation. Some of these details are actually on Wikipedia too. They document that it's 315 megahertz and 868.3. But the coolest thing about this is that if you have a really nice antenna, you can actually point it at all the windows of a building and then just send everybody turn on, or everybody turn off, or turn on only certain lights, because they actually have IDs. So you can see, oh, third floor, fifth window over. That room has ID 127, okay? The next room over is ID 128. And you figure out which ones just by evaluating RSSI, so you can determine where the likelihood of that chip is in the physical space, and then bam, you've got the ability to start playing around with specific windows. Adura is another company that has enabled building technology. So they've integrated Enotion to provide wireless RF technology for entire buildings, skyscrapers, et cetera, which is pretty exciting stuff. And this is the data format, which is straight from the FCC. This stuff you wouldn't be able to get without paying money. So it shows you the exact data format. So now you don't even have to do a lot of research. What most people do when they look into new technologies like this is they have to purchase the technology, like go out and purchase the Enotion developer kit, say, for like $5,000, and then buy the licensing technology or whatever to implement the demo, and then you will have access to the documentation and tools to reproduce this. But what's awesome is that now we have the ability to do this exact same thing from anywhere from $15 to $50, thanks to one awesome hacker named Atlas and Travis Goodspeed and a couple other guys that assisted with the, RFCAT project. So RFCAT is the sub-gigahertz network Swiss Army knife, essentially. This is really cool stuff because for a couple of bucks, you can buy a little wireless dongle with a whip antenna, and you can get pretty decent ability to transmit on it. You can transmit for about 50 to 100 feet in distance, so it allows you to do a lot of interesting research for like dollars. So what's cool is that you can integrate the data that you find online on the FCC about Enotion's packet technology, and you can take it around in the city in KL and start sniffing for these packets without ever having to get a demo system from Enotion, which is incredible, right? Because used to it would have cost thousands of dollars. Today it costs anywhere from 15 to 50 USD. And bam, you now have the ability to interact with entire building automation systems that you never would have been able to touch before, all because of the brilliance of M2M, right? That's exciting stuff. So, overall, hacking has absolutely nothing to do with the latest, most complex, most incredible thing that people have done to date. It's awesome when we see exceptional technology deployed, like the Pod2G guys and the other iOS Dream Team. Those guys are like, they're my heroes, right? Because they're awesome, they're incredible. But at the same time, hacking doesn't have to mean doing such complex, time-consuming things. Sometimes hacking means understanding all of the technology well enough that you can implement the simplest, most effective attack in the shortest amount of time. That, to me, is what real hacking is. Getting the solution in a timely fashion, okay? So overall, yeah, there are going to be some bad guys. There are going to be bad guys out there that tell you that zero-day is wrong, that we shouldn't be working on zero-day technology, and we shouldn't be doing anything dangerous for the information security community. But the fact is we need zero-day. We need people that are sitting around with lame laptops, looking at code, and finding simple things to do. Because dumb little tricks like the SSH transparent man in the middle are real. And they will be used in the future as these attacks become more popular again. And the next time that there's some kind of an instance where SSH has a new key type, it may be used again. And we need to understand that there are scenarios that we need to relate to our users to ensure that they're armed with the knowledge to make sure that they are not going to be compromised by these stupid, simple tricks. Because let's face it, any Bumsville in Idaho can get hacked by a kid like this. And we're seeing it all over the place today, right? SQL inject, lulzsec, anonymous, blah, blah, blah. It's everywhere, and it's not going away, ever. And that's why we need to talk nonstop about these issues. Thanks so much for having me.